Section 5.1 today. Only section 5.1. And what I was able to do in the previous class was finish early, and we got to talk a little bit about what we did yesterday in college algebra, which might not be a bad thing, okay? So we're going to, as soon as we finish 5.1, if there's extra time, we'll spend some time on My Math Lab going through the problems from yesterday's assignment. Today we're on page 298, and today we're talking about rational expressions and functions. Rational expressions and functions, page 298, okay? And it's kind of interesting, the title, the way they have it written, what they mention first is what we're going to do last. So we're actually going to talk about rational functions first, and then rational expressions. Starting with number 7, and they give us a function. All right, so can everybody tell that that is a rational function? And what makes it a rational function? Fractions with variables in the bottom. Thank you, Mackenzie. Fractions with variables in the bottom. Now, what they ask us to find is the domain. And what I want to know from you is, does a rational function have any restrictions? Exactly. The only restriction for a rational function is that the denominator cannot be 0, okay? So if we're going to find the domain, the first thing we need to find are the restrictions. And we know for a rational function, the denominator cannot be 0. You follow me? So we're going to take the entire denominator, and look what I said. I said that stuff cannot be 0. And then if I solve this for x, I'll know what x can't be. And if I know what x can't be, then I'll know what x can be, right? All right, so here we go. Did you notice that this equation is quadratic? But since there's only 2 terms, I think I can solve by factoring. So what do these 2 terms have in common? And that means I am able to factor out an x. What will that leave me with? And now those are multiplied, so now I've got 2 factors. Can I now set each factor equal to 0? So we're going to say x equal to 0, which really that means x cannot be 0. 3 minus x, moving the x over, says x cannot be 3. So how many numbers can x not be? Are there any other restrictions? Are those the only restrictions? Yes, because the only thing that a fraction cannot have is a 0 in the bottom. So those are the only restrictions. Now we can write the domain. Would you like to use set notation or interval notation? And we'll go with set notation first. And does everybody remember what set notation looks like? That we have to have the braces. We have to have an X because we're talking about domain, right? It's the X's. And what does this vertical line mean? Such that. So this is the set of all X, such that, and then what goes here is always the restriction. Such that X is not equal to 0 and 3. And so that's the domain in set notation. And again, this basically says, hey, X can be anything but 0 and 3. Now, let's also write that in interval notation. Are you ready? So if 0 and 3 are the only exclusions, that means that we can take any number all the way back to negative infinity up to 0, but not including 0, union, and then we're going to skip over 0 and keep going to which number? Oh, but a parenthesis because we cannot include 3. But we can skip over 3 and keep going to infinity.
Okay, so you did the 0, 3 because we're skipping 1 and 2 also.
No.
Oh, okay.
1 and 2 are included.
Okay, so I guess I don't understand.
This part of it?
Yeah.
Or the whole thing?
No, I understand the ends. It's
Okay.
the middle I don't get.
Okay, so if I were to look at this on a number line,
Right.
and if I put 0 and 3, I would have to have open circles because those are not allowed, right? But anything else is. Any other number is allowed, okay? So anything from minus infinity up to 0, anything from 0 to 3, that's what that says,
Okay.
and then anything from 3 to infinity. So these 3 intervals correspond to the shading on the graph that's allowed.
Got it.
That help any?
Yes, thank you.
Okay. Would you like to try another one? Because that one is done. Okay, next problem. Let's try number 11. And we have another function, f of x equals. And we have the same set of instructions. Here it says find the domain. Is this a rational function? Everybody knows how to identify it as rational? You got to have a fraction. And what else? Variables in the bottom, yeah. And does a rational function have a restriction? What is it? Okay, so then what we're going to say is we're going to say, okay, if I'm going to find the domain, then I'm going to have to set up the restriction, which says that x squared plus 12x plus 35 cannot be 0. And then what kind of equation is that? Okay, and since it has all 3 terms, I'm going to have to consider a technique to solve that. Okay, so do y'all remember the 3 techniques that I covered in class? What were the 3? Completing the square, quadratic formula, and factoring. And remember, factoring was first because it was easiest. Completing the square came next because you can't have the quadratic formula without completing the square, okay? So how would y'all like to solve this? Factoring? Well, guess what? We're not going to factor it, okay? We're going to complete the square because I'm so afraid that y'all are going to forget how that works. So we're going to do completing the square. You don't have to like it. You just have to watch and see how it works, okay? So to remind you how that works, to complete the square, the first thing you have to do is move the constant over. If you're going to complete the square, the constant has to move over, okay? Now, do y'all see that I left an empty spot here?
That's what I always forget.
You got to leave an empty spot because the constant that I got rid of, I'm now going to replace with my own constant, okay? It's kind of like when a company gets bought out and they bring in their own people, okay? So I fired the 35 and now I'm going to bring in my own people, okay? Do y'all remember how we come up with the new constant? We're going to take the 12 and half it. Half of 12 is, and then what do we do with that? You half it and then you square it. There you go, Edson. Look at Edson. I saw the synapses firing right there. I could actually see the sparks coming out of your ears. It was awesome. So you half it, you square it, and that's your new constant, right? But whatever I do to one side, so I also have to do a plus 36 on the other side. And now if you look closely, I've got a new trinomial. You'll see now I've got a new set of 3 terms, and it's going to factor nicely. So can you read the signs?
Same.
They're the same and they're both plus. I've got x and x to make x squared. And I'm going to need 2 numbers. The numbers have to multiply to make 36 and add to make 12. 6 and 6. And y'all remember when I taught completing the square? I said this is always going to match. It always factors as a perfect square. And on the other side, I need to do the math. Good. 1. Now, can I simplify the left-hand side? Anything times itself is that thing squared. And now do y'all know how to get rid of a square? Oh, it's radical, dude. Yeah, that's a radical move. Bam. Whatever I do to one side. And so we're going to square root both sides. The square and the square root cancel. Does anybody happen to know the square root of 1? I don't think you need a calculator for that. Yeah. Square root of 1 is 1. No, that's not a trick question. And does anybody know what the 1 needs? Remember when you square root both sides, you need a plus and a minus. And we're to the last step. Red Rover, let 6 come over. And that's going to give me negative 6 plus or minus 1. And now I can write my domain. Okay, so here we go. With set notation first, we know now that the domain is going to be the set of all x's such that x cannot be negative 5 or negative 7. Those are the 2 numbers x cannot be. Do you see where I got those from? Yeah. So I did the plus, negative 6 plus 1, and then I did the minus, negative 6 minus 1. How about interval notation? So everything from minus infinity up to Good. Union. Everything from? Yep, good. And everything from? And does everybody understand when you're writing the interval notation, it has to represent the shading on the number line from left to right. And that's why the -7 absolutely has to go first. Because we're moving from left to right, you encounter -7 first, and then -5. Do y'all have any questions about doing the domain of a rational function? Okay, so let me hit the high points again and we'll move on, okay? Remember, a rational function has a restriction. The denominator cannot be 0. So you're going to set the denominator equal to 0 and solve. And those are the numbers x cannot be. All right, moving on. Number 27. We've got t squared minus 16 over t squared minus 8t plus 16. And the instructions say simplify. Simplify. So normally, what does it mean to simplify a fraction? If you simplify it, you're going to... I'm looking for the R word. Reduce it, okay? So, let's consider a simpler problem. What if I had 2/4 and the instructions say simplify? Okay, and why is that? By? Because, what'd you say? Right, okay. So, but what if I said show your work? So does everybody agree that 2 can be written as 1 times 2? And 4 can be written as 2 times 2? And then do they have a common factor? And what happens to those 2's? They cancel. So the technique that I just demonstrated is what we're going to apply here, okay? So what was my first step? I wrote those as factors. So we're going to have to factor these first. Now, does anybody recognize what the top is? Difference of 2 squares, and you're going to need to know how that factors. What are the signs for difference of squares? Always different. And then I need a t and a t to make t squared. And then I need 2 numbers. 8. Or is it 4? Why is it not 8?
Multiply.
Oh, they got to multiply, right? If I do the FOIL method, I'm multiplying. 8 times 8 is 16. No. 4 times 4 is 16. And you know what? We had the exact same thing happen in the previous class. Somebody said 8. Yeah. We got to have a nice discussion like we just did. So everybody understand why it's 4 and not 8? Okay. Now in the denominator, I have a standard trinomial. Can you read the signs? They're both going to be negative. If the last sign is plus, they both have to be the first sign. I've got a t and a t to make t squared, and I need 2 numbers. Is it 4 and 4? 4 times 4? And what about a -4 plus a -4? -8. Isn't that great? Y'all agree?
Oh, and look.
Oh, and look. Now do we have any common factor top and bottom? T minus 4. And does it matter which T minus 4 I take in the bottom? Can I take them all? No. Got to take them one for one, right? One in the top, one in the bottom. And now to say what I normally say when I teach this, what I've said the last 25 years I've taught this, factor and cancel. Whatever's left is the answer. So the answer is T plus 4 over T minus 4. And is that simplified completely? Or can I say, hey, cancel the T's? And hey, cancel the 4's? And do y'all know why that's not legal? Well, I guess 1 or 0. Those can be answers. But is there any legal reason why I can't cancel those out?
Because they're connected.
They're connected by what? A plus or a minus. Okay? So do y'all see the reason I can cancel these is because they were connected with multiplication. So this guy is a factor, right? Factors are things that are multiplied. But what is the T by himself over here? Is he a factor or a term? And you cannot cancel terms. You can cancel factors, but you can't cancel terms. And have y'all ever heard me say in class, part of the thing about learning math is you got to learn where to stop, right? Sometimes you got to know when to stop. Because I've had people, they go crazy, cancel, 0. And you know what? You can probably find a way to make any problem 0 like that, is start canceling all the crap out. Are y'all ready for another one? All right, here we go. Another problem. How am I doing on space? I think I'll squeeze this one in right over here. How about number 30? And we've got... All right, so the instructions say simplify. We're trying to simplify again. And is anybody looking at these two problems, do you see that they both have a y squared top and bottom? And then can I cancel those out? Why not? Oh, they're terms. They're not factors. Okay, so what did I just say a second ago? I said factor and cancel. Whatever's left is the answer. Okay, so we have to factor first. And lucky for us, we have 2 standard trinomials. Can you read the signs? The top's going to be different, but the bottom signs are going to be the same. They're both negative. And then we got y's all around. Don't ask me why. We just got y's all around. And then I need numbers for the top. Is it plus 9 or minus 9? 9 minus 1 makes a positive 8. I agree. What about bottom numbers? And does it matter where I put them? Nope, because they're the same signs. 4 and 1. Now that I've F'd it all up, I factored it all up, is there anything I can cancel? So factor and cancel, whatever's left is the answer. And now would y'all like to crank it up a notch? All right, so we're going to go to a new page, start fresh with number 39. And this time the instructions say multiply and simplify. Multiply and simplify. Okay? So the nice thing about this is that it is multiplication, and that means we get to leave it the way it is. Multiplication is where we want to be. And my phrase still applies. Factor and cancel, whatever's left is the answer. But this time we've got 1, 2, 3, 4. We got 4 pieces to factor. Let's F it up. In the first numerator, what do I have? Difference of 2 squares. So what are the signs going to be? Always different for difference of squares. X and X. 4 and 4. So far, so good? Now, can I factor X squared? Well, I don't think we ever talked about factoring a monomial, did we? No, but we can factor it. And some people may go, why would you do that? Well, I felt like it, okay? And I'll show you in a second, okay? Why that's needed. Next, in the numerator, how many terms are there? Do they have anything in common that I can factor out?
Yes.
What do they have in common? They both have an X. So I'm going to be able to factor an X out. And do y'all remember when I taught the section on factoring, I said factor out has to come first. What will that leave me with? X minus 4. And then in the denominator, I have a standard trinomial. Can you read the signs? Negative makes them different. X and X. And I'm going to need a couple of numbers. 4 and 3. And where does the 4 go? So 4 and 3. Does everybody agree? Now have I effed it all up? And now let's cancel some stuff. What do you see is going to cancel? X minus 4, X minus, remember it's only 1 for 1 though. 1 in top, 1 in bottom. Anything else going to cancel? X. Now do you see why I split it up? Because now I've got an X and an X that can cancel.
So you can go to the second.
As long as it's top and bottom, you can listen, you can reach across multiplication. You can reach across as long as it's top and bottom. When we go to where it's addition and subtraction, you can't do that. But for multiplication, you can. Now then, those X's are going to cancel. Is there anything else going to cancel? And so whatever's left is the answer. X plus 4, X minus 4. And in the bottom, I have an X and an X plus 3. So you know what this section is really going to get you good at is factoring. Because you got to factor a lot. Would y'all like to do another multiplication example, or would you like to move on to division? Yeah. Let's see. Mom chicka wah wah. Let's see. Okay, fine. How about 44? Sometimes it's hard to choose. Which one it is? Kind of like looking at your kids and going, which one is my favorite? It's hard to choose. 44.
Do you have a favorite?
Favorite kid? Everybody does. Everybody has a favorite kid.
You're not going to say because you're recording.
No, you can't. You can't say which one is your favorite. Everybody has a favorite. I mean, you can't help it. It's human nature. Are any of y'all parents, by the way? Nobody in here is a parent? Okay, well, let's keep it that way. Let's keep it that way for a while. Wait till you graduate. Are y'all ready to F it up? All right, so I'm noticing I've got 1, 2, 3 pieces that are going to factor. Did you notice the y plus 4 doesn't have an exponent? And so that makes him linear, and he's not going to factor, okay? Also because he doesn't have anything in common that I can factor out. So he's just going to have to sit there and wait his turn. So what about the first numerator? I've got a standard trinomial. Can you read the signs? Affirmative. Y and Y. And I'm going to need a couple of numbers. 9 and 1. And does everybody understand why it's not 3 and 3? 3 times 3 is 9. But 3 and 3 is 6, not 10. Okay. Next, in the denominator, I've got the difference of 2 squares. So the signs are always different. 1 and 1 make 1 when you multiply. Times the y plus 4. He's going to just get looked over. And I've got another standard trinomial. Can you read the signs? They're going to be different. Y and Y. And I'm going to need a couple of numbers. Nine and 4. And where does the 9 go? With the negative. Now, why is it 9 and 4? Because 4 times 9 is 36. And if I subtract 4 minus 9, I get negative 5. So that's why that factors that way. And now that I've F'd it all up, is there anything that's going to cancel? A lot? Okay. Y plus 4s? Y minus 1s? Y minus 9. Now, did y'all notice that everything in the top canceled? So if everything goes away in the top, what is still left in the top? A 1. And in the bottom? Y plus 1. I like that one. A lot of stuff got to cancel. And it's important that you realize if everything goes away in the top, there is still a 1 left in the top. And do y'all understand why? For 2 reasons. If I put like a 1 here, does that change that value? No. So there's a reason why the 1 is still there. The other reason is because when we cancel, we're doing divide. So what is anything divided by itself? And that's why there's a 1 left in the top. Because you're dividing, you get a 1 left. Now can I move on to division? And we're going to drop down to number 57. I was just thinking, if I was a high school teacher, could I ask that question? Do any of y'all have any kids? And it wouldn't always necessarily be no in high school. That's just occurred to me. All right, so there's the problem. And do y'all notice the thing that's different? Division. So if you have division with fractions, your goal is to turn it back into multiplication. Your goal is to get back to being a multiplication problem. So what we're going to do here is we're going to do the KCF. Do y'all know what the KCF stands for?
Keep, change, factor,
Well, we are going to factor, you're right. But it's keep, change, flip. Division with fractions, you're going to keep, change, flip. So the first fraction, we're going to keep it the way that it is. We're going to change division to multiplication, and then we're going to do the 4-letter F word, flip. We're going to flip the last fraction. And would you like to factor on the fly?
yes.
Okay, let's factor on the fly. Bam, bam, bam. Bam, 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 bam. Times. Bam, bam, bam. And so that's a good start.
I like it.
And do y'all understand why I stopped and didn't put 2 sets of parentheses in the bottom back there? Y'all understand why I stopped? Because this guy's going to go to the bottom, right? And does he have an exponent? So he's not going to be a square. He's not going to factor with 2 sets of parentheses, okay? Because he doesn't have a power. So let's factor the difference of squares. X squared minus 16. X plus 4. X minus 4. Difference of squares. In the denominator, we have a trinomial. Let's read the signs. They're both going to be minus. X and X. And I heard 5 and 5. Does everybody agree with that? 5 times 5, 25. Negative 5 and negative 5 add to make negative 10. I agree. Okay, now remember the second fraction is going to flip. So the denominator is a trinomial. He'll end up in the top. Can you read the signs? They're going to be different. I heard 2 and 5. And I just assumed the 5 goes with the negative. Because 2 minus 5 makes negative 3. Everybody agree? Now, for the last piece of the puzzle, I've only got 2 terms. What do they have in common? And so I'm going to factor out the 3. What will that leave me with? If I factor out the 3, it leaves me with x minus 4. And now we've effed it all up. Let's cancel some stuff out. X minus 4, top and bottom. Top and bottom. And that's it. So whatever's left is the answer. And in the numerator, we have x plus 4, x plus 2. In the denominator, we have a 3 and an x minus 5. And that is done. Would you like to see another one? One more, please? Okay. Because I got one that I wanted to do with the last group and I didn't get around to doing it. So I'll do it with y'all. Yeah, number 62. Fun, fun, fun. All right, so what is the first thing that you notice? Okay, that's the first thing you notice is that, and we haven't done any cubes yet today, have we? So notice we have the sum of two cubes and the difference of two cubes. We're going to get to practice the cubes. What else do you notice that we need to address? Yeah. If you've got division, you're going to have to turn it into multiplication, and that's going to be the KCF again, okay? So do y'all want to factor on the fly? Okay, here we go. 1, 2, 1, 2, 1, 2, 1, 2. Now, do y'all remember when we're factoring the cubes that the second set of parentheses is a little bit wider because there's going to have to be a trinomial there? Do y'all remember that? When you're factoring the sum and difference of cubes, the second set of parentheses is wider. Okay, so what I want to do is I want to go ahead and address these cubes. Let's go ahead and F them up, okay? Do y'all know what three things make 8y to the third? 2y, 2y, and 2y. And what three things make 27? 3, 3, and 3. Do y'all see that? And you need to write that stuff down because we're going to be pulling from it in a second. Okay? 2 times 2 times 2 is 8. 3 times 3 times 3, 27. And now we're going to have to get the signs. Do y'all remember what we used to get the signs? Soap. Y'all remember the soap? Remember my joke? Soap is only for cubes and dirty people. Y'all remember that? Okay. So SOAP stands for, so same. The first sign is going to be same as the problem. The next sign has to be opposite. And the last sign is always positive. Same, opposite, always positive. What about in the bottom? Same, opposite, always positive. And now we're going to fill in the blanks. We're going to take a 2y and a 3. And the 2y and the 3 fill in the first two blanks. And then we're going to square, multiply, square. So what is 2y times 2y? 4y squared. Y'all see how we get that blank right there? You're going to go 2y times 2y. And then we're going to go 2y times 3. And then we're going to go 3 times 3. And that's how you factor the cubes. And if you didn't fully catch that, we're going to do it again, okay? Down here. So does anybody know what three things make 64? Yeah, 4y, 4y, and 4y. And what three things make 1? 1, 1, and 1. And now we're going to factor the bottom here. We've already got the signs. So let's come up and grab one of each. We're going to grab a 4y and a 1. And then we're going to square, multiply, square. 4y times 4y. 16y squared. And then 4y times 1. And 1 times 1. Got it? Now, remember the second fraction? Since we had division, that guy's going to flip. And the denominator is a trinomial with a lead coefficient, and I'm not going to try to factor him.
So that's why you did.
That's why I didn't put the parentheses up there, is because I was planning on not factoring that guy. And do y'all
Because
see?
he matches.
Oh, you see now, don't you?
Okay.
That's why I didn't want to bother with him, is because he was going to appear down here. So what's going to happen to this guy and this guy? Do y'all see that? Cancel and cancel. Now we can finish the job. We have the difference of two squares, which has different signs. And then I need you to fill in the blanks. 2y and 2y make a 4y squared. 3 and 3 make 9.
So then there's the other 2y plus 3.
Okay, I heard that. 2y plus 3 cancel. And is that everything that's going to cancel? So the answer is 4y squared minus 6y plus 9. 4y minus 1 times. And if anybody's thinking about, no, wait a second, what about that numerator as a trinomial? Should we try to factor that to see if it matches one of these? Is anybody thinking that? Let me tell you why you don't have to think about that. Where did this trinomial come from?
What we cubed out, the
Yeah.
addition.
Did it come from a cube? The trinomial that comes from a cube will never factor. It's always going to be prime. And so you don't have to worry about factoring that.
Can you say that one more time?
The trinomial that comes from a sum or difference of cubes will never factor. Does anybody have any other questions about this section? Anything in the section? Okay, so what I'm going to do is I'm going to go ahead and